C1 Quadratics, exam question, January 2005, question 10. So we've got a quadratic function. In part A, we need to express the function in the form x minus a all squared plus b, where a and b are integers. Now you need to recognise that form there. That is when we complete the square. So you'll get familiar with these types of questions and you need to spot when the question's asking you to complete the square. So if we complete the square for the function, we need to half the coefficient of x. The coefficient of x is minus 6, so we half that. So it's x minus 3 all squared. If we were to expand that as it is, we're going to get 9 on the end, so we need to subtract 9. So we don't want 9 on the end. What we do want is 18. So we need to subtract the 9 that we're going to get on the end and add 18. We collect that together. Minus 9 add 18 is 9. So we've completed the square, and a is 3 and b is 9. In part B, we're told that this curve meets the y-axis at point P and has a minimum point at Q. So we need to sketch the graph showing these coordinates. Now, because we've already completed the square in part A, it makes it much easier to sketch now. So because we've completed the square, we know the vertex, as it's in this form, x minus p all squared plus q, where the vertex is pq. So if we've got minus 3 in the brackets, the vertex will be at 3. The q value is 9, so our vertex or turning point is at 3, 9. Now we already know that the graph crosses the y-axis at 18. If we look at our original question, the y-intercept is 18. We know it's a positive parabola. And we've just found this vertex here, which is 3, 9. So the minimum point of the graph is 3, 9. So we've got our x-axis, our y-axis. We want to find the coordinates of P and Q. So P is the point where the curve meets the y-axis. So P, we can see is 0, 18. And Q is the point which is the minimum point of the graph. So the minimum point is at Q, and we found that by completing the square, that the minimum point or vertex is at 3, 9. So that's part B for 4 marks. For part C, we're now told that the line y equals 41 meets this curve at the point R. So the line y equals 41 is going to be a horizontal line that intercepts the y-axis at 41, and we need to work out, obviously it's a lot higher than this, but we need to work out the point, or the x-coordinate, where it intersects the curve. And if we look at this, we're looking for the positive solution. So we know that y is 41. So we've already written our equation by completing the square. So we've written it in this form, x minus 3 all squared plus 9, and that's equal to y. But we want where that y coordinate is 41. So if we put it equal to 41, when y is 41, we want to find out our x coordinate. So we just need to rearrange and solve for x. So if we subtract 9, 32, we square root both sides, got root 32. Now, looking back at that question, it just asked for the positive root, so we're not interested in the negative root. If we move the 3 over, got 3 plus root 32. We can simplify that third. 32 can break down into 4 multiplied by 8. Now by doing that, we've not actually looked for the biggest square number. So by using 4 and 8, we can do it that way. But there's actually a bigger square number than 4 that is a factor of 32. So let's make that easier. By using 16 and 2. 32 can be broken down to 16 times by 2. So we've got x is equal to 3 plus 4 root 2. That was the form that the question asked us to give our answer in. P plus Q root 2. So our value of P is 3 and our value of Q is 4.